Welcome to the Ftir.fun Infrared Learning Series. This episode, Ep39 Expert Sub-micron Chemical Imaging. We will cover every key point section by section, then close with a checklist. Next, IUting infrared absorption with visible. In March 2022, Marchetti et al. From Politecnico di Milano published a study in Science Advances that drew significant attention in heritage field IC. Using optical photothermal infrared O-PTIR spectroscopy, we achieved sub-micron chemical imaging 450 nanometers of 16th century heritage glass metal composite objects, non-invasively without sample preparation, and with spectral quality matching conventional SIR. This breaks the infrared diffraction limit by OSI 20-fold. Marchetti et al. Next, O-PTIR principle visible probe snoops on infrared absorption. 1.1 core idea to break the diffraction limit. Recap from Ep36 and Ep38. Both conventional F and centrotron fir are constrained by the infrared diffraction. They may today approximately equal 0.61 mm, which is metered micrometers at 1000 centimeters. To break this limit, one must use shorter wavelengths for eye imaging. Next, IE comprehensive comparison with SIR. 2.1 core to mammometer comparison. Table 1. FIR-S Exploiter comparison data sources. Marchetti Sci and V. 2022. Binary Methods 2023 UI. Next, IN. Non-contact, non-destructive core advantages of O-PTIR. 3.1 Why is non-contact so important? All three modes of conventional SIR have limitations. Next, DPS Case 1 Characterization of 16th century artifact glass metal composite. In 2022, Marchetti's team published a study in Science Advances. It is a landmark work of expert in cultural heritage conservation. The object of study is a 16th century Renaissance enamel glass metal composite badge. Structure: copper alloy substrate plus multi-layer glass enamel. White, blue, green, red. Challenges: enamel layer thickness 5200 micrometers. The chemical gradients at sub-micron scale cannot be sectioned, destructive to artifact. Cannot use a tree contact. May scratch enamel. Traditional reflection SIR is limited by diffraction limit micrometers. Cannot resolve chemical gradients solution. O-PTIR non-contact sub-micron chemical imaging. Next, deeper Heath Case 2 IML of Frontiers. 5.1 Single-cell expert imaging. O-PTIR's 450 nanometers resolution is exactly suitable for subcellular structure imaging. Mitochondria 1 micrometer. Endoplasmic reticulum 0.5 micrometers. Lipid droplets 0.582 micrometers. The nuclei 5 micrometers are all within O-PTIR resolution capability. Next, REI. To briefly Case 3 Materials Science Frontiers. 6.1 Polymer blend phase separation. Phases separated structures in polymer blends, e.g. PP, platica, are typically on the 0.510 micrometers scale, exactly within the resolution blind zone of conventional FIR. Next, V. Limitations and challenges of O-PTIR. Limited spectral range. FICAN QA's step tunable, typically covering 800-1800 centimeters plus 2700-3000 centimeters. Thin 1800-2700 centimeters and 3000-4000 centimeters. Requires special QCL. Thin Farrenford 800 centimeters not yet available. Compared to SIR A. Full spectrum 4400 centimeters. There is a gap. Spectral library compatibility. O-PTIR spectra are highly similar to SIR but not identical. Direct SIR library search may yield low C. Dedicated expert reference libraries are needed, currently small scale. Next, BOA. Position of O-PTIR in the infrared spectroscopy technology. Spectrum. 8.1 Infrared microscopy technology spectrum. 8.2 Selection Decision Guide. Next, thought questions. O-PTIR uses visible light to detect infrared absorption, thereby breaking the infrared diffraction limit. Please explain this physical process in detail. Why is the final resolution determined by visible light? Compare the advantages and disadvantages of these O-PTIR and potential transfer for single-cell imaging. If you need to study A. The overall protein secondary structure of a single cell without subcellular resolution. B. The lipid distribution within a mitochondrial network. Finally, the drill actualists. Make sure you can recall each item. Core knowledge point. Key points. O-PTIR definition. Photothermal infrared pulsed air pump plus visible probe detection. Breaking the diffraction limit. Uses visible light detection resolutions 450 nanometers. Breaking air diffraction limit by air 20 times. Physical process. Air absorption thermal expansion plus refractive index change. Visible light scattering modulation locking detection. Air pump source. Q. Pulsed. Segment-tuned or OPO. Broadband. Visible probe light. 532 nanometers green light, most common, or 785 nanometers red light. Biological samples. Spatial resolution. 450 nanometers. 532 nanometers probe, or in 500 nanometers, 785 nanometers. Non-contact and non-destructive. Completely non-contact, suitable for cultural heritage. Live cells, semi-mixed ondox. Aqueous samples. Water is transparent to visible light, enabling live cell imaging in buffer. Spectral range. 801,800 centimeters plus 2,700, 3,000 centimeters. QCL segmented. Spectra vs. Third. Highly similar but non-identical. Dedicated libraries required. Cultural heritage case. 16th century enamel badge identifying glass corrosion products, organic residues, chemical gradients, pineapple, live cell lipid droplets, mitochondrial networks, leading edge of cancer nests, materials science, polymer phase separation, semiconductor defects, catalyst acid sites. Main limitations. Limited spectral range, thermal diffusion blurring, quantification difficulties, high cost, competing technologies, ftir, higher resolution, contact mode, synchrotron, high SNR, diffraction limited. That covers the required sample for this episode. Practice with real spectra on ftir.fun, and continue with the next lesson.